Okay, so the goal of this problem now is to determine the pump curve, so to express delta P as a function of the volumetric flow rate. Well, a delta P has to do with a force, volumetric flow rate with a velocity. So you will have to impose. The principle you will have to use are related both to momentum and mass. So you will have to write the Newton's second law for control volume and conservation of mass in that case. So now how do you pick a control volume? Here, well, usually you want to pick a control volume which is related to the quantities that you are looking for, and you want to pick the bounds of your control volumes where you actually know stuff. Okay, so in this case, a very obvious boundary for your control volume will be the outlet here, right? Because at this outlet, you know exactly the velocity, you know that it's uniform and it's u0. And at this outlet, you also know the pressure, you know that the pressure acting is P0 plus delta P. So this is an obvious choice for one of the boundaries. Now clearly, you will just want to take the fluid inside of that pipe, right? There's no reason why you would cut inside of the material here, so you just take the fluid inside of the pipe. Now the question is, where exactly do you want to end this control volume? Well, the most obvious choice is to end your control volume again where you know stuff. So you could end it right after the nozzle, because after the nozzle, you know what's happening here, you know what's happening at the exit of the nozzle, you know that the velocity is uj. So this control volume here, which is independent on time, is the most obvious choice for control volume. Now, it's not the only choice. For instance, you could decide to pick this control volume here. So same thing, you're taking the control volume at the end, and here you cut through the nozzle, and you finish it right there at the inlet where the flow is also uniform. Now this is a bit, in certain cases, it could be an interesting choice of control volume, and it would be an interesting choice of control volume if you were asked, for instance, to characterize the force exerted by the wall onto the outlet of the pump. So the force exerted here at this location here, exerted by the wall to hold this nozzle, this bent nozzle here fixed. Then it makes sense to cut through, because this is exactly what you're interested in. But this choice here, given that you're not asked about this force, the first choice of control volume here is more obvious. And if you pick this control volume here underneath, you can try it. But at some point you realize that when you look at the forces on your surface, you have to know the forces exerted by the wall onto the nozzle, and so you would have to then isolate another control volume, which will be just the nozzle here. So it's a bit less direct. So in that case, I would really recommend the first control volume. So this control volume here.